Okay, so this video is meant for my geometry students. We have a quiz coming up on Thursday, Friday for my white day people. So, got 6 questions to go over, 3 proofs, and 3 other things. Okay, so first, we have this triangle congruence. Triangle EFG is congruent to triangle HIJ. It just says list the congruent corresponding parts. There are 6 total parts. 3 sides and 3 angles. So we need to list all of the congruent corresponding parts. First, we start with EF. Segment EF is congruent. So EF is first and second, so go to HI. So then we keep going. Segment FG is congruent to segment, keep going, IJ. And then last, go first to last. Segment EG is congruent to first and last, HJ. And there are the 3 congruent sides. Now we go to the congruent angles. And if there's no pictures, you can just name them with one letter. So angle E is congruent to angle H. Angle F, so that's the second letter, is congruent to angle I, second letter, and angle G is congruent to angle J. Corresponding congruent parts. Okay, here's problem 2. Problem 2 is asking, is angle RKT congruent to angle UKT? And it should say explain. There are 2 ways you can go about doing this problem. Okay, the first way. I know that angle R is congruent to angle U, and I know that angle RTK is congruent to angle UTK. You know that 2 of the 3 angles are congruent, so we know this thing called the third angles theorem. In this third angle theorem says that if 2 angles are congruent in one triangle to 2 angles of another triangle, then the third angles are also congruent. So therefore, angle RKT is congruent to angle UKT. So that's the first way. Okay. The second way you can think about it is look at these congruent triangles. Look at the triangles. You have a lot of ways to show these triangles are congruent based on how they're marked. You have 2 options. You have let's go right here with these sides, these 2 sides, and then this angle in between. You have side, angle, side. So the triangles are congruent. So triangle TRK is congruent to triangle TUK by side, angle, side. Therefore, the corresponding parts of the congruent triangles are congruent. Angle RKT is congruent to angle UKT by CPCTC. Either way you want to do it, I don't care. It's your preference. Okay, here's your third problem. It says determine whether triangles must be congruent. If so, name the postulate or theorem that justifies your answer. If not, explain. So let's look at what we're given. Understand that there's 3 ways, right, to prove triangles congruent. Let's use blue. Or 4 ways. There's side, 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 angle, side, angle, side, angle, 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 side, right? All need 3 parts. So what do we have right now between these 2 triangles? And again, maybe I should name the triangles. So let's say this would be triangle, let's say ZVY, or, ZVY. Is it congruent to triangle? So ZVY, so it looks like Z and W correspond. The V's correspond because they're congruent, and then Y down here. So is this the case, is the question. So what do we have? Well, first, I have angle Z is congruent to angle W. There's one pair of angles. Cross off, side, side, side. It's not going to happen. Then, I have angle, and I'll call it ZVY, is congruent to angle WVY. Right here. It's these 2 angles. That's another pair of angles. So now I cross off side, angle, side. So the question is, can I get a pair of sides somewhere? And the answer is yes. Vy is congruent to itself. VY, segment VY, is congruent to segment VY. That's a side. This is by the reflexive property. And I have two angles and a side. This side is not in between the angles. VZ and VW would be the sides in between the angles, right? But they're not congruent. It's the non-included side, which means it's not ASA, it's AAS. So yes, they are congruent by AAS. Angle, angle, side. Boom. 3 down, 3 proofs to go. Okay, here's the first proof we're going to talk about. I have these two triangles. I'm given that angle V is congruent to angle Y. So I'm going to write that down. Wait, I'm going to delete this one in just a sec. Okay, my apologies. So hopefully you had time to copy down the picture. Statements and reasons. My given goes in my first statement spot. So I'm given that angle V is congruent. That's angle V is congruent to angle Y. I also know that WZ bisects angle VWY. That's all given to me. I have to prove the two triangles congruent, so I know that side, 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 angle, and angle, angle, side are all ways to do this. Let's mark the picture. Angle V is congruent to angle Y. That's one pair of angles. So there goes side, side, side out the window. So now I have to get these other two pieces of information to prove the two triangles congruent. Well, look at your second given. Segment WZ bisects angle VWY. Go to angle VWY. It's this angle right here. And split it into two congruent parts. 1, 2. That's the next step. Angle VWZ is congruent to angle. Now follow the correspondence. YWZ. And that is because this bisected an angle. Definition of angle bisector. And there's another angle. So I cross off side, angle, side because it involves two sides. Now I need to come up with the third piece of information. And that third piece of information is going to be the side in between them. WZ. WZ is congruent to WZ, and that is by the reflexive property. And there is a side. So now the question is, how are the triangles congruent? Are they congruent by angle, side, angle, or angle, angle, side? This would have to be the side for it to be angle, side, angle, and it's not. It's the side here. So it's not angle, side, angle, it's angle, angle, side. So the two triangles are congruent. VWZ is congruent to triangle YWZ by angle, angle, side. Okay? One proof down, 2 more to go. Okay, here is the next proof here. We're given a lot of information here. Okay, so write all this down. So I have two sets of perpendiculars. Segment PQ, perpendicular segment QS, segment RS, perpendicular to segment SQ, and then I have a midpoint. T is midpoint of PR. That's all given. I have to prove that angle P is congruent to angle R. So notice this is not congruent triangles. So this is going to be CP, CTC, but I first have to prove two triangles are congruent. Those two triangles, I'm going to name them PQT, PQT congruent to triangle. Now the correspondence would be RST. And there's 4 ways to do it. Side, 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 angle, side, angle, or angle, angle, side. One of those 4 ways needs to be used. Okay? So what we're going to do is we're going to first use that they're perpendicular and mark right angles. And say that angle Q and angle S are right angles. They're the only angles there, so we can name it with one letter, and that is by the definition of perpendicular lines. So now, if they're both right angles, we know they are congruent. Angle Q is congruent to angle S. They are congruent. That's because all right angles are congruent. And there's a pair of angles. And I cross off side, side, side. Next, it says T is midpoint of PR. T is in the middle of PR, so that means that these two sides are congruent. So for PT, segment PT is congruent to segment RT. Use the correspondence correctly. And that is because it's a midpoint. Definition of a midpoint. And there is a pair of sides, so all are still fair game. And now the last thing I need is either another angle or side. Well, look at how the two triangles touch. Look at those two angles right there. Those two angles are vertical angles. Named with 3 letters. Angle PTQ is congruent to angle, so that's PTQ RTS. And that is because they are vertical angles. That's the vertical angles theorem. And there is my last pair of angles. So it's not going to be SAS, it's going to be 2 angles and a side. Is the side in between the angles? The side would have to be in between the angles, right here and here. It's not. So it's not angle, angle, side, or angle. It's not angle, side, angle. It's angle, angle, side. So triangle PQT is congruent to triangle RST by angle, angle, side. But now we have one more step. Now I'm going to scroll down. Now that the triangles are congruent, we know that all the other corresponding parts are congruent. So now we know that angle R, or angle P, I'm sorry. First spot, angle P is congruent to angle R. And that is by CP, CTC. Now we're done. Every proof requires congruent triangles. If it doesn't end in congruent triangles, CP, CTC is that last step. Okay, one more proof. Okay, last proof, here we go. So what am I given? I'm given that angle FJG is congruent to angle HGJ. I'm also given 2 parallel lines. Immediately you should be thinking about more angles. Parallel lines lead to more angles. Notice what I want to prove. I don't want to prove triangles congruent. This is going to be CP, CTC. But in order to use this, I have to prove 2 triangles congruent. So what are those 2 triangles would be? Well, let's go FGJ would be congruent to triangle. So F to G would be the same as H to J. H, J, and then G. And I know 4 ways to do this. Side, 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 angle, side, angle, side, angle, 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 side. Okay? So I have my picture marked, right? FJG congruent to HGJ. My 2 sides are parallel. So this is one pair of angles. So I cross off side, side, side. I'm going to get another pair of angles from these parallel lines. Watch what I'll do. I'm going to extend the parallel lines. And I'm going to draw the transversal extended in between them. See the Z that is formed. See this right here. We have alternate interior angles here and there. Step 2. Angle FGJ is congruent. So that's FGJ is congruent to angle HJG. That is because these are alternate interior angles, and there's a theorem about that. Excuse me. And there's a second A. So over here I cross off side, angle, side. We're not going to use it. We're going to use the ones that have 2 A's. So the question is, where does the last piece come from? I need a side. Well, look. They touch. Segment GJ is congruent to itself. That is reflexive property. And there is that side we needed. So now the question is this side in between the angles? It would have to be this side. And look, it is. That's the side I marked congruent. So this is going to be angle, side, angle. Triangle, FGJ is congruent to triangle, HJG, and that is by angle, side, angle. But that is not what I wanted to prove. I want to prove that FJ is congruent to HG. Well, look here. FJ is first and last. HG is first and last. They are corresponding parts of these congruent triangles. Therefore, they are congruent. And that is by CP/CTC. Note sheets completed. Note cards made. This YouTube video watched and recorded, and then the proof worksheet. If you have all that done, I cannot see you doing poorly on this quiz. Thanks for watching. We'll see you on Thursday.